Imagine an object in the universe so massive it could swallow billions of suns, yet fit into a region smaller than our solar system. These cosmic giants are called supermassive black holes, and they lurk at the very centers of galaxies, including our own Milky Way. Today, we'll explore their formation, their unimaginable power, and their mind-bending influence on the cosmos and why understanding them changes everything we thought we knew about the universe. So, what exactly is a supermassive black hole? A regular black hole forms when a massive star collapses, crushing its core into a point of infinite density called a singularity. But supermassive black holes are a different class entirely. They can weigh millions, or even billions, of times the mass of our Sun, yet they are shockingly compact. Their immense gravity warps space and time around them in ways that defy intuition. At the heart of our Milky Way lies Sagittarius asterisk, a supermassive black hole with about 4 million times the mass of our Sun. It's completely invisible, but its presence is betrayed by the stars caught in its grip, orbiting at incredible speeds. How do these cosmic behemoths even form? Scientists are still piecing together the puzzle. One theory suggests they began as colossal stars in the early universe, which then collapsed directly into massive black hole seeds. Another idea is that smaller black holes merged over billions of years, growing larger and larger like cosmic cannibals. A third possibility is that they grew by accreting enormous amounts of gas and dust from their surroundings. Whatever their origin, one thing is certain: these objects dominate the hearts of galaxies, controlling the movement of stars, gas, and even entire galactic structures. Let's talk about the sheer scale of their mass. Picture a black hole 10 billion times the mass of our Sun. Its gravitational pull is so extreme that nearby stars are whipped around at thousands of kilometers per second. As matter gets pulled in, it forms a spinning accretion disk that heats up to millions of degrees, blasting out X-rays and gamma rays that can be seen across the universe. And here's the paradox. Despite their colossal mass, these supermassive black holes occupy a volume smaller than our solar system. It's a cosmic contradiction that truly challenges human comprehension. Surrounding the central singularity is the event horizon, the point of no return. Here, gravity is so overwhelmingly strong that not even light, the fastest thing in the universe, can escape. Time itself behaves strangely near this boundary, a phenomenon called gravitational time dilation. If you were to approach a supermassive black hole, hours could pass for you while centuries ticked by for everyone else in the universe. But these cosmic monsters don't just suck in everything around them. Instead, they bend the very fabric of space-time, controlling the orbital dances of nearby stars, gas clouds, and even entire galaxies. Supermassive black holes aren't just cosmic curiosities, they are the architects of the universe. The incredible energy they release can regulate star formation across an entire galaxy, either by blowing away the necessary gas or compressing it to trigger new births. They influence how galaxies collide and merge, ultimately determining how they evolve over eons. Some galaxies host quasars. These are active supermassive black holes, so luminous they outshine all the billions of stars in their host galaxy combined. Quasars act like cosmic lighthouses, their brilliant light visible across billions of light-years, giving us a glimpse into the distant past. Matter that falls toward a supermassive black hole doesn't just plunge straight in. It forms a swirling accretion disk, spinning at nearly the speed of light. The friction and intense gravity in this disk heat the material to millions of degrees, producing powerful X-rays and launching relativistic jets that shoot out for thousands of light-years. These jets are cosmic sandblasters, powerful enough to reshape entire galaxies by clearing out gas and dust. In this way, supermassive black holes are both destructive and creative. They are cosmic engines that constantly sculpt the universe. But how do we study something that's invisible? We can't see black holes directly because their gravity traps all light. Instead, astronomers look for their telltale signatures. They track the orbits of stars that appear to be circling an empty point in space. They detect the intense radiation pouring out from the superheated accretion disks, and they listen for the gravitational waves, or ripples in spacetime, created when two black holes merge. As we've touched on, time behaves very strangely near supermassive black holes. Gravitational time dilation means that the stronger the gravity, the slower time passes. Imagine a team of astronauts orbiting just outside the event horizon of a supermassive black hole. For them, only a few hours might pass, but when they return to Earth, they'd find that decades, or even centuries, have gone by. This isn't science fiction, it's a real consequence of Einstein's theory of general relativity. It is a powerful reminder that the universe operates on rules far stranger and more wonderful than our everyday experience. So, just how big can these things get? Some supermassive black holes are billions of times more massive than our Sun. One of the reigning champions is in a distant quasar called Ton 618, which weighs in at an estimated 66 billion solar masses. That's almost incomprehensibly large. Yet, if this monster were to replace the Sun in our solar system, its immense gravity would dominate. But Earth's orbit would likely remain stable. This shows that a black hole's influence is all about distance. These giants reveal the extreme possibilities of cosmic evolution, dwarfing everything we consider normal. Why are we so fascinated by supermassive black holes? They're more than just scientific curiosities. They represent a frontier of physics, forcing us to reconcile the world of the very large general relativity with the world of the very small quantum mechanics. They expose the limits of our own imagination and remind us how small and fragile we are in the grand scheme of the cosmos, but they also inspire wonder. They are the cosmic engines that shape galaxies, influence the lives of stars, and create the spectacular fireworks we observe from Earth. A supermassive black hole can weigh as much as billions of suns. It bends space and time, controls the fate of entire galaxies, and challenges everything we think we know about the universe. These cosmic giants remind us that the cosmos is stranger, larger, and more powerful than we can ever fully comprehend. As we continue to explore the final frontier, supermassive black holes will stand as timeless symbols of mystery, power, and the endless reach of human curiosity. Subscribe for more cosmic mysteries, space science, and mind-blowing discoveries about the universe we call home.